right, we are live. Today we're gonna continue the damn vulnerable Defi. So we finish the first one, unstoppable. Today we're gonna be the naive receiver. Today we're gonna really try, do only 30 minutes of live stream, and that includes if we don't finish today, we're gonna finish the later one, another day. Right, just let me just post about that here on LinkedIn, and then I'm gonna start. I already have my Z browser, Z IDE, and also I'm using here the Zen browser. So with the Z, I think the Zen also written in Rust, if I'm not mistaken. Take some tea here. Today I'm using the camera here below. You can see the tea here. Testing new angles. Starting live stream. Damn vulnerable DeFi hug. You now. YouTube and Twitch. Right. I need to post the image there. And the link. Where is the link? Okay, already 2 minutes in. I don't remember where I get the link. And for some reason the chat is here. Okay, I think I found from YouTube. Just let me check. And I'm gonna check the chat too. Okay, the audio, it's fine. Maybe it's too. No, it's okay. Hi. Okay, for me working here. I see some comments said that the volume is low, but fine here to me. Okay, so happening now. Everything active. Only my chat here. I think if I close and open, no. Yeah, I don't know why. Let me see. Why the chat's not working? Chat is ready. Yeah, that's something wrong. Very wrong with the shots. Oh, show up. Okay, that's working, I guess. Yeah, it is. Great. So I think the Twitter gonna work too, right? So let's start. First, let's get in the right contract here. we finished the unstoppable one, the first one. And today we're gonna go with the naive receiver. Right. Let's try understand again the prompt or the challenge, right? There's a pool with 1000 Ethereum and balancing offering flash loans. It has a fixed fee of 1 Ethereum. Okay, you can take, if that a pool with that amount, you can take and paying 1 Ethereum of fee fixed. The pool supports meta transactions by integrating with the permissionless forward contract. Okay, that one, if you don't know what it is, you can copy and put in a cloud, for example. But if I'm not mistaken, that's ERC 2027 AIP. No, it's AI agents. No, it's not that. So ERC, what they call, it's the same using the GNS blockchain. It's gas network station, right? Gas network station. Yes. GSN. It's the same protocol used here. We could ask for Claude answer, but I think it's good to show that one too. So yeah, you can pay gas with any token, or pay gas with anything. So let's see if they're gonna show the pattern. 20 gaslet, yeah, the meta transactions. We have the relay, the paymaster, and the forwarder. We're gonna need to understand how that works before trying to hack. Okay, yeah, I am close, right? I was very close. Not too close, but yeah. Oh, they are already exposing the vulnerability there. Okay, so that's their RC. They call Secure Protocol for Native Meta Transaction, a contract interface for receiving meta transactions through a trusted forwarder. Created by a lot of people that I never heard of before. Maybe Patrick. Gavin Youth. Okay. Oh, it's not Gavin Youth, it's Gavin John. Fabian, I think it's Brazilian, right? Frozen May, I don't remember. Okay, so the IEP defines a contract level protocol for recipient contracts to accept meta transactions that should be through trusted forward contracts. No protocol changes are made. Recipient contracts are sent the effect message sender heifer to underlying message sender and data as underlying message data function by appending additional code data. What's the motivation? There is a growing interest in making it possible for Ethereum contract to accept calls from externally owned accounts, AOA, that do not have Ethereum to pay for gas. Solutions that allow for third parties to pay for gas costs or call meta transactions. For that purpose of these IEP, meta transactions or transactions that have been authorized by a transaction signer and relayed by an untrusted third party that pays for the gas relay. All right, so they have here some draw. Unfortunately, that's in in not dark mode. Maybe that one is dark mode, right? No. Here he's kinda using the architecture, but they have a little more stuff. GSN is like implementation for that one. So okay, so we have the transaction signer signs and sends transactions to gas relay. The gas relay receive signs and sends transactions. Probably that's off chain, right? Yeah, off chain. So sign send request off chain to gas relay receives a signed request off chain from transaction signers and pay gas to turn it in a valid transaction that goes through a trusted forwarder. Trust forwarder, a contract trusted by the recipient. Who's the recipient? Who gonna receive? Oh, OpenSense, boa noite pra cima, bora. Did you see that they changed the damn vulnerable DeFi? So it's the same challenges names, but they upgraded all the challenges. So the first one, unstoppable, they have a new AIP for implementing the flash loans. And that one now, I don't remember how was the first one, but I have that saved in my computer. Now they implemented meta transactions, so that force people to study the new patterns and check for vulnerability. Very cool, right? Okay, so the trust forward is here. A contract used by the recipient to correctly verify signatures and nonsense before forwarding the request from transaction signers. Okay, so we have the signers. That's like me, the gas relay that's gonna basically pay the gas. So we're gonna take my transaction, make that valid, and if I'm not mistaken, I'm gonna pay the gas, and then I'm gonna send to the forwarder. I just don't remember where the message is, but I'm gonna check. And the recipient contract that accept meta transactions through a trusted forwarder. Okay, we have a sign and send off chain. The gas relay send and verify request. Okay, yeah, that's paying the gas. That's a contract. That's off chain. And for example, gas relay here, the gas station do the off chain part. I don't know if they explain here. Yeah, the fancy name, a relay server that can user transactions and pay for the gas cost itself. Okay. Yeah, send and verify requests. The trust forward verify the signature, and inside, I think inside that one, where you have the message sender function that check for the sender. Because what's happening here is, because who is executing the transaction is the gas relay, the message sender now is not the transaction signer anymore. So you need to have a way where you can take the original message sender and data from the signer to go through the call data to the contract. So that's why you have the custom function here. So extracting, yeah, like I said, extracting the transaction signer address. So the forwarder is responsible for calling the recipient contract and must append the address of the signer, 20 bytes of data, and then the call data. So we have here a call passing some values, and then they encode the data with the from. So they take the call data they receive, append with the address from and the end. And then do the call, right? The recipient contract can then extract the signer address by performing 3 operations. First, check that the forward is trusted. How did this implement? It's out of the scope for the proposal. All right. Extract, that's cool. That's important maybe for our security checking or auditing, right? Extract the transaction signer address from the last bytes for the call data and use that as original sender of the transaction. Instead, message sender, because if they use a message sender, that's going to be gas relay. And we don't want to use gas relay. If the message sender is not a trusted forwarder, or if the message data is shorter than 20, then return the original sender itself. Okay, so the sender here, it's the for the recipient, the sender is going to be the trusted forwarder, right? And so they need to check if that's the trusted forwarder or if the data is shorter than 20, because if it is shorter than 20, we don't got well, we don't want a lot of stuff, right? What is data here? Because if I calling just a function, that should be a list for, right? Okay, that works. Oh no, yeah, because you can call a contract with 0, right? Yeah, you can call a contract with 0 data, just sending values. So we need at least 20 bytes, not 24. And 24, you're gonna create a bug. Okay, then return the original sender as it is. So if it's not trusted forwarder, then return the original sender as it is. So what's happening if I call the contract directly? So instead I'm using the relay. I have gas, I call the contract directly. So I just need to works as it is because I check if the sender is the trusted forwarder. So the trusted forwarder here is just works as a way. One way do you verify if you somebody is forwarding the call. So to be able to take the original address, right? Simple, right? Okay, the recipient must check if that's trust forward to prevent if, yeah, I just said that. So the recipient must check that it trusts the forwarder to prevent it from extracting address data appended from an untrusted contract. This could result in a forwarded address. So what? So check for that's trusted. Not clear how that's working. I think it's a list, right? List of address. And here the recipient. So the recipient is who implementing, right? Must check that it trusts the forward to prevent it from extracting address data appended from an untrusted contract. Okay, I'm gonna pretend I understand that. I think they said is if you put if I'm malicious and create a contract and you accept as a forwarder, then I can change the message sender internally, right? Yeah, I think so. Okay, protocol support discovery mechanism. Unless a recipient contract is being used by a particular front end that knows the contract has support for native metadata, it should not be responsible for offer user choice using meta to interact with contract. Okay, about the discovery, right? As a recipient could trust, so wait, it not be able to offer choice. We does need a mechanism by which the recipient can let the world know that they support the transaction. The especially important meta transaction to be supported at Web3 wallet level. Such wallets may not necessarily know anything about the recipient contract user may wish to interact with. As a recipient could trust forward with different interfaces and capabilities. Transaction batching, different message signing formats. We need to allow wallets to discover which forwarder is trusted. To provide the discover mechanism where a recipient contract must implement the function is trusted forwarder, true or false. Must return true if the forward is trusted by the recipient. Otherwise, it must return false. Okay, let's go directly for the. Okay, that's another project I was working on. Let me close that one. And here, let's also, that's another thing I was working on. What's my Z? Wrong place. That's why. It's number 2, right? Yeah. It was in number 3. Yeah. Okay, so we have here flash loan receiver using the flash borrower. We have the lender. So lender who takes, borrower who gives. Multi call. So just to able to, how the name says, multi call. Using delegates. And that's our contract. Okay, let's see here. There are pool, but the balancing offering flash loan. Okay, so the pool, it's not that one. So the fixed fee, not the ship's flash loan. Callback success, need to return that one. And immutable. So in the first challenge we did, I go through very slowly. That time I'm gonna try go more fast where I think the bug is. Okay. Also, I think we have the test here for the naive. And that's a good way to start too. So here we have the pool with the 1000 Ethereum and the receiver has 10. I don't know why. Let me keep that open, double click to keep it open. And a user deploy a sample contract. Okay, I see. A user deploy a sample contract with 10 in balance. Looks like it can execute flash loans of Ethereum. All funds are in risk. Rescue all Ethereum from the user and the pool and deposit it in the designated recovery account. Oh, why I misreading that one? Yeah, I'm misreading here. I stop. User deploy a sample contract with 10 Ethereum. Okay, so what is the sample contract the user deployed? I think it's another pool, right? Deployer, recovery, has a recover, deployer, and deploy private key. We have the pool, the Ethereum, the flash loan receiver, the basic forwarder, where that's the forwarder trusted, right? AIP 712, it's the signature stuff, right? And here the trusted forwarder. All right, we have yeah, the type hash is from that one. So they're gonna have from target value gas nonce data deadline. That's the nonces, the check, and here the targets. So the target need to implement I has trusted folder. Check request. Check request and revert when they're not valid. A valid request must include the expected value, not be expired. Include the expected nonce. Target a contract that accepts this folder. That's internal. Execute. I see. So they need to accept each other. So they only can trust one address. So imagining that the target it's me as a contract. When they check who they trust, they need to return that address, because if it's not, they have an invalid target. They cannot not execute. And here they check and recover who signed the request to take the address for the signer. If the signer is different from who requests from, so we have invalid signer too. So we can have a bug here. We could check that one too, if they're gonna return something right or not. I think it's right. Looking here, looks like right. Oh, whoops. Maybe not. Yeah, maybe that can be broken. Need to be checked. Oh, maybe not. It's check. Just put in the memories. Three put in the memories. Yeah, the define, destruct the hash, and then take back as digits. Yeah, maybe it's correct. How I come back, I forgot. Yeah, Control O and V. All right, so here they check if the value is different from value. So the value on the signature is different. They check the deadline, the timestamp. They check the nonces from the address request from, because they assume the here is the same, so that's not a problem. Basically, here that's the transaction sign off chain. I say I want to run on the target, the value with the nonces, and the data with the deadline. And the user sign that message using the old kind of AGMAC, I don't know how to spell that in English, 8MAC, right? Where you sign and hash in a way where people can do revert and find who's the address that signed it. And here, I think it recovered it's inside from OpenZeppelin. Yeah. I don't know if you're gonna. Yeah, the recovered it's internal for EVM. They have an internal contract for that. Where it is? Try recover. Wait, it's another try. Okay, that's a signature. 1, 2. Ah, yeah, they have another try recover. Should be that one. Okay, yeah, that one. EC recover. Also, they check if it's for not malleable bug. All right. and already almost 30 minutes. Okay, let's try break that. So they have the pool, here they check and the setup. So we have the player P key. We do OAX for the deployer, and I think they put money too. The OAX put monies. Yeah, put a lot of Ethereum for us. Then they deploy the contract, the basic folder, and deploy a pool with fund with the 10. It should be 10, right? No, that's not 10. That's 1000. That's the 1000 pool. And they set the folder, they trust it's that one. And they accept the token, that's the deployer. If we open here and we check the trusted forward, it's immutable, so it's defined only once. So it's safe to assume that's never change. And here we have, okay, also they put a value inside the, why they call naive receiver, right? Here we need to have a function to receive the Ethereum, right? Wait. That's payable. That should be a receive function to receive stuff, right? Or that's not needed anymore. In that version, they don't need anymore. Okay, let me assume that they don't need anymore because they are taking value here. Let's see. And they have the pool deploy flash loan receiver contract and fund it with some initial Ethereum. So here the receiver flash loan passing the pool. So they receive the pool here on flash loan. They're gonna load the pool variable, that's the address slot, and check if they equal the color. It means only the pool can call flash loan function. That's a callback. And here they store probably the signature for something, the error in that case. So if that's a 0, if that's not the case, they're gonna revert with the error. That name, that's the position of the memory. We're gonna return. And if the token asked is different from what's defined in the pool, revert to amount be repaid should be amount plus fee. Execute the action during flash loan, and then returns fund to the pool. So approve the pool to amount to be paid, and that should be the same as defined there in the constants. Has the function. There's no function where the funds received will be used. Huh. Funny, right? Looks like it's missing something. Okay, receiver. Ethereum deposits some Ethereum. So that contract should be have receive. That has receive. So receive as a payable. I don't know why virtual. Don't need it. They need it. Oh, because they can extend, right? And deposit. So they're gonna mint the value that deposit for the sender. So looks right. It means if you deposit some Ethereum, you're gonna receive some token in the same value. Let's see if it's correct in the sense of, yeah, that's using probably Open Zeppelin token. Yeah, I'm gonna assume that it is. And then here the test. So the assert initial state, it's check if the pool has the value. What's the variable here? Receiver 10. Oh, so that's they said about user. User deployed a simple contract with 10 in balance. Simple contract. That don't make any sense for me. What they doing here, it's they deployed indeed. Deploy flash loan receiver contract and funded it with some initial Ethereum. Oh, true. They transfer here. So I have, because we have withdraw here, right? You can put the token there and take the money. So yeah, user naive, deploy the receiver and deposit some money. So what we need to hack is that one. We need a way to take money. We save what? The 10 Ethereum? All funds are at risk. Yeah, indeed. Rescue all Ethereum from the user and the pool and deposit it to the, yeah, we need to post because it's something wrong here about that and probably that. Okay, let's see. Here they doing nothing, right? You just need to remember. Okay, if you receiver the deposit, we're doing deposit here. Deposit do what? Call deposits with amounts. Oh, that's why they don't have a receive here. Because our transfer to, yeah, makes sense now. Make a lot of sense. I wonder if I remove that function, if they're gonna break because they don't have a receive in the end. They have at least one receive, right? Otherwise, they're gonna call callback. I think that's the case. All right. So here we have deposits made for the messages sender. That's the pattern that we were studying here. They have a recipient example with the forwarder and the sender here. So in the sender, they take the sender, call signer, check the data, check the truster, and do some call data size, subtract for 20, call data load, 96, shift to take the signer. Security consideration. Malicious forwarder might forward the value of sender and effectively send transactions from any address. Therefore, recipient contract must be careful in trusting forwarders if a forwarder is upgradable, then one must also trust that the contract won't perform while it's upgraded. In addition, modifying which forwarders are trusted must be restricted, since an attacker could trust their own address to forward transactions and therefore be able to force transactions. It's recommended to have a listed trusted forward to be immutable, and it is not feasible, then only trusted contracts owner should be able to modify. Yeah, that's cool stuff. So that's the pattern they have, like this construct the concept from the IP to have multiple contracts to be implemented. One context where they take the sender and data, and where is here the sender. I'm gonna see the implementation here. They are not using the flash loan. That's the lender, right? Who can borrow? Lender who can provide. Yeah, and that's the fee. Here we call and the receiver who's taking the money. So can I, with the debt contract, take a lot of money? Now, what's strange for me is that here's the pool. I allow only the pool calling the callback, right? So the pool, when we call flash loan past that contract, he transfer Ethereum handle control to receiver. All right. They transfer the amount they asked, and the total deposit they subtract. And here they do the flash loan, and here they update stuff. Yeah, the problem looks like it's already here, but I think we need to gonna finish that tomorrow because of time. But basically here we are calling the flash loan, right? And they check if the callback success is returned. So if that's get returned, that was implemented correctly. If the flash loan take the money, do something, they expect the amount they ask plus the fee, and then they transfer from the receiver to these the amount they need to have, and they sum up here. Right? So here can revert. Here we can revert. The fixed amount is just a sum. The data, I think it's not used. Right, let's see the test again. Yeah, so here they check with the pool, have the initial value, the receiver have the initial value, here that should be the everything that 1 Ethereum, and the fee receiver should be the deployer. Cannot call receiver, so revert if receiver call the flash loan, because they only accept be the pool calling. And here my solution. And how we gonna check? They're gonna check that the player must have executed 2 or less transactions. The flash loan receiver contract has to be empty. The receiver should be without money, the balancing from the receiver. The pool is empty, all funds sent to recovery address. All right. Yeah, looks like the same or similar with unstoppable, right? So here on the stoppable, what we did was that was more simple. We just broke this stuff, but they do the loan, right? Where they do the loan? Status fees. They do after. They do after my test. Initial state here. I think it's solved. They check. They check just the status. Yeah, it's not the same. Yeah, try and go fast, as I promise it's something I cannot handle. I think I need to go slow to figure out. But basically, something withdraw, reduce deposits. So deposits, sender. If sender is who is calling, it's equal trusted folder, and the data is greater than 20. So the sender gonna be who I said. So basically, right? Take the end. Let's take the end, right? I'm gonna assume that it's taking the end. Message data length less 20, and cut 20. Yeah. Yeah, that's exactly doing that. So who is trust folder? Is defined in this constructor. Is the basic. So if the basic call the sum function here, so for example, it's raw, I can take money from other address. So that's the problem, right? That's a part of the problem. So if somebody has some deposits, oh boy. So here we transfer from that contract, it means the pool, to address we want. So for example, the amount here, I can put 1000, put my address, and call from the folder, passing my real address and the end of the call function. And then I'm gonna withdraw, clean the pool. So that's the first part. And here we have the deposit too. That I don't think we're gonna use, right? Maybe we're gonna use, how we gonna clean up the receiver? Oh, we clean up paying the fees. Ah, right. Yeah, so we cracked. So because the user need to pay fees, a fixed fee, we need to run a for loop for 10 times. We need to take money 10 times. We just need to do that, take 10 times. That's why that implementation do nothing and they don't care what they do, because they're just paying fees. So let's start write some codes. So for example, here in our solution, if we take who you are here, player, it's the user, check solved by players. I think player is the user, right? Yeah, because he's deployed all that stuff. So let's go call a receiver, and I don't remember how to do autocomplete. Yeah, no, we cannot call. Wait a second, I just forgot how to do. I think it's pool flash long, right? Yeah, we need to remember how to do that. Flash. Yeah, who we're gonna receive? I don't do. They don't care who called, right? We don't have address this or message sender for me. Oh, they have. So message sender here is who there? Initiator. So who need to be the initiator for that one? They don't care. They really don't care. That's missing some checks there, right? Right, so let's go. What's okay? Receiver token amount data. So pool flash loan, the receiver, and then the token. Yeah, almost there, right? I don't think they have the fee here. Yeah, because it's receiver, the token. Here I need to do address too. Oh, I don't need it because they expect the interface. And how much we're gonna take don't matter, right? We cannot take everything. So we can do at least 10 times. So from the pool, it don't matter, right? We're gonna just give back. Yeah, let's go 1 Ethereum and data. They don't think they have. Oh, let's go 1,330 and data. It's not necessary. Yeah, so here if you go for, I don't remember how to do for loop here, probably as usual. Right, it's not a deficient. No, I think it's deficient, right? So because it's 0 first and less than 10, they're gonna run 10 times, right? So let's run that bad boy here. Wait, how I did that? Okay, I need to configure for test, and instead it's gonna be naive receiver. They're gonna fail, but one part gonna works. Yeah. So here's the test. They check the player nonces and the balance. I need to save, right? I don't know why it's not saving automatically. Yeah, now I'm gonna run 10 times. Okay, underflow, nice. Because I tried to more than, oh yeah, I tried to more than they have. They need to be ether. Oh shit. They don't have all that money. So let's go in a way. Can I type way? Okay. Why I cannot save anymore? Yeah. All right. Yeah, you see here they run 10 times in the checks. So here return true. Here they received. Stop denounces. Player nonces. I don't know why the nonces is still returning 0. And the balance, unexpected balance in receiver contracts. Yeah, that's 0 now. So that's return true, right? Because they expect 0, they return 0. So we get 0 there. In the pool, now we have 110 to be taken. That's why it's failing. It should be 0. So the second part we do, it's calling pool withdraw. They expect, that's not right. Withdraw expect some amount. So the amount should be, we can use the variables. Wet in pool in receiver, we can sum up both. I forgot all my shortcut. Hold Ethereum pool plus receiver. Yeah. If you want, we can go even like, yeah, that's too fancy. But we can like put 10 here. Yeah. Now we go to who gonna receive, right? We can go direct for the recover address. I think it's recovered, it's already address. Wait, what am I missing? No. It's a variable, right? Recovery, of course. A special name. Okay, withdraw. Because it need to be payable. So payable. I think they need to payable. I think they need to be address too, right? To be payable. I don't remember. Valid type argumentative function, valid implicit conversion from address to address payable requested. Now it's fixed, right? Yes. Okay. Now it's missing something. No, it's not missing anything, right? I think we cracked. See. Okay, 1 hour. Oops. Oops. Oh, of course. It's missing the extra data, right? So we need to call that with extra data. So if I'm not wrong, if I remember correctly, we need to call not like that. We don't need that one, right? We go directly. And here we go ABI encode from, yeah, exactly, with signature. In the signature, it's withdraw int address. I don't need to be payable because that's gonna just form the signature, and then you pass the arguments first, second. Why it's not payable? They don't need it. Member count not found or not visible. Use address pool. Yeah, indeed. Indeed. Now I need to encode package what my address or the cover address, right? I think that is right. What? Okay, let's run. Wait. Pool? That's a pool, right? Withdraw, external, receiver. Because they call sender. Oh, wait. Yeah. The sender. The function should be called by the trusted forwarder. Yeah, that's something I'm missing. The trusted forwarder, it's the basic, right? It's that one. Let's see if we can break. Here, execute, pass some requests with signature, and they're gonna do just call for us. So we just need to call that with some request, sign for call target value payload. Payload is to be data with the request from. Yeah. So if I want to send, yeah, I can send for myself, then myself will recover, right? Oh, that's why they don't allow the nonce has more than 2. Right? Here you're gonna increase the nonces twice. Once and 2. So here they check if must have the good 2 or less. Okay, so that's enough for us. I think we can take the private key, like we can run as recovery and make that works too. But okay, let's go with mode. So instead do all that stuff, we need to go forwarder. I don't know why it's not working. Yeah, it's forward. It's not forward. It's execute. That's AI. Okay, I think it's still wrong. Okay, execute. So the request, we need to build. And let's remove all the stuff. We don't understand what we want. Let's see the type request, where it is. It's called basic folder inside, right? So if you go basic for it's plural, yeah, equal request. Now I think they understand. Yeah, I want to create it to not. My goodness. From player, right? Player. Because I need to sign, and that's why they give me private key. 2, we're gonna execute so-called targets. Targets the pool. The value is 0. The data it's the ABI. We could put all that stuff in a variable, right? Oh, that's right, I think. Because the targets, they have value, they have gas. Really, I think I can put 0 here. They have nonces. Let's go 0, 2. And they have data in that line. That line can be block timestamp plus 30s. I think it's right. Maybe it's not. Maybe block timestamp here is not right. Let's check the function again. So here we need to build. So check request revert when it's not valid. Valid request must include the expected value. Okay, of course. Not be expired. Include the expected nonces. So here in nonces, we have probably 0. So if they are different, they're gonna fail and they're gonna increment later. So that's just the checking, right? And the target it should be have implemented the trusted forward as these. That should be okay there because I think pool has that cover, right? No. Wait a second. They do not have. The target must wait. Target. Yeah, we're gonna call for target. Target is the pool. I think it's implemented here, right? No, it's not. Wait a second. Where we saw the implementation? Oh, they don't have implementation. So the target need to be returning the base key for the address. Strange. Yeah, how are we gonna do the target implemented? Where is that implemented? Oh, wait a second. Wait. Ah, that's it is right now here. Here. That's a function, right? So that's correct. They're gonna pass. So that's gonna pass the timestamp greater than that line. Ah, we did just need to put 0, right? Anything it's greater than that line. Oh, it's old should be the great. If the timestamp is greater than that line, so we can go like, what's the time the timestamp size? I don't remember the size. Okay, just need to see the line types. Request. Yeah, so let's go max. Type max, right? That's one, just to not break. Okay, that should be infinite. So always gonna work. 0, 0, 0. Nonsense should be 0. The first one. I think it's byte. Okay, we're missing something. We're not missing anything, right? Open, close, open. Oops. Open, close, wrong argument count. Expect 2, indeed. The second argument is the signature. So here is the checking. Here we can get the hash for us. That's public. So we can get the hash and they call hash type ticket, that's internal. Here, return the hash for fully message for this domain, give instructor hash defined as etc. So the hash can be used together with the recover to obtain a signer of the message. So type NBN code, blah, 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 call signer recover. So that's the digits. That's the digits and the signature. Encodes, I think that's the structure, right? No, that's the first param. Yeah, that's a kind of signature, the first param, the second param. And then put in the hash typed to recover. Funny because I don't have access for that. Neither him. That should be enough. Yeah, because they have here request type hash. Type hash. Yeah. Okay, the second one is signature. We need to sign that. I don't remember how to sign in Foundry. I need to private key VM sign. Yeah, I don't remember. And probably the AI gonna say something that don't exist. Yeah, player key, blah blah blah. Don't make any sense. Signature, it's bytes, right? Should be forwarder. No, yeah, it's forwarder. Get the hash request. Bytes 32 hash and here just checks if the function is not called. Here is checking the request to against this signature to recover the signer. I just don't remember really how to do in Foundry. Let me. Oh, Lucas, come on, Souls Fortis. So, do you remember how to sign? I think I used that in Gardens once. using Foundry. I don't remember. So let's go to cloud. How to in Foundry. Oops, Foundry. Sign a transaction. No. Sign a hash for the EIP pattern. That should be fine, right? Indeed, sign. So I was right. Yeah. Private key in the digest. So the problem is they have that one here built for us, but we cannot use it. And that's very sad. And they expect signature as one thing, right? So here in the execute, there are a lot of bytes together, and we recover, gonna break the signature in 3 parts. As you can see, RSV. Let's see if that's the order. No, it's not the order. So yeah, I remember you need to put in the right order, and they are expecting in that format. And I'm tired, so I should be doing that manually, where I need to check if they have the right set. To be honest, that should be easy, right? 20, 20, 20. That if it's not 20, that's not 20. You need to put in 32 bytes. It should be 20. But I don't want to screw up that stuff. So, for cleaner approach, Foundry also has the typer sign type data add more resettling, but sign how type data works. Oh, so that's more easy. That's probably gonna return signature. Where is you? 1 hour. I never can do in 30 minutes. Okay, anyways. So here I want so bad they have a easy function to do that for us. Why they took so long? Deal there. Oh my god, they are not. Jesus Christ. Yeah. AI don't know anything. Okay, let's go to the AI. Just like give me the answer. It generates signature digest to be that will be using ecdsa.saw with recover. Now I think they're gonna find sign. I have my private key. They keep insisting to build that one. I don't want to build that one manually. Hash uchus. That's cool for OpenZeppelin. Okay, that's uchus. And then they take the tree and they say they can accept the tree. The problem is I need a signature. Yeah, see the order. I don't think impact opact gonna works. I don't think so, but okay. Yeah, basically I need to that one and the signature. And the digits we're gonna figure out later. So let's go P. VM sign should be player. PK. It should be hash for now. Not right, but we don't care. And here should be, I think we need to cast for, oh Jesus, 32, right? Wait, 20 bytes plus 8, 160. I think we need to cast that one. Almost sure we need to cast. And that should be the signature. That's gonna fail because the get data hash, it's missing one part because they encode the request type, the data itself, but they need to domain separator and oh boy, where it is. That's internal. Yeah, where that's used. Really? That one? Wait a second. What? Ah, here. We will use the digest to store the domain separate to save a bit of gas. Here, hash can be used together with the recover to bit and assigner of messages. Should be what you did plus that one. So I want to take that one, but it's okay. That should be here. That should be here, right? Really? Cryptograph opens Zeppelin. Open Zeppelin. ACD. Where is ACD? Here. Hash juice. Nice. So that's for Ethereum sign messages. That's not what we're not using. We are using that one. Why? I don't know why. Why not that one? Ah, here. But that's 0, 0. And that's 0, 1. Nice, 0, 1. To type, yeah, domain separator and struct hash. The domain separator should be the really version hash, name version. They okay, they okay, okay. So if main change, if not, they use a cache. So the pattern is naming version just together, right? It's separator and hash. Oh, with China ID and address. What the fuck? Everything, right? Domain hash. Oh my goodness. Okay. I think they built that for us. Or not. I need to build the domain separator. Man, that's so ugly. Okay, let's go. Still need to build domain separator and the info or shit. So the info for this is separator inversion hash. So it's the hash for the name inversion, and that's implemented here. I just need the hash for both these. Let's see if they're gonna understand if that's hashed. Yeah, they took the hash, so that should be our stuff. Or oh, I knew it. I knew it. They have something. I just don't remember. Yeah, they have. What do they don't have? Wait a second. They have or not? Probably they have because but you are using Soul Lady. And Soul Lady save stuff in different places. Here. Name inversion. What the? Okay, let's copy. I don't know if that's copied. Disavoid rebuilding manually guarantees matches that contracts use internally during recovery. Yeah, that should be. Or sometimes they explode as domain separator. Because they hash only the two parts in here, they return as private. And here that's public. They return only the parts. So that's internal. That's kind of stuff that to allow people save gas, but make us cry as developer. Ah, my goodness. I'm using Soul Lady. Let's take more tea. You see, it's taking more time to figure out that than the hack itself. Solidly expose its public function, so you don't need to build them yourself. Let's see if that's true. I don't trust that's true. I don't know why they don't search. Because I'm new. Yeah, that's internal. EIP type hash internal, indeed. Yeah, if they have a function to sign for me, they don't have. They get hash. We have the domain separator. We have, that's internal. Oh boy. Yeah, let's build manually. Why not? That may be gonna break, but I don't know why. I forgot every time. Okay, chain ID, that should be the target. So what's that? So sad we need to do that manually. Very annoying. Like hash utus. Can we use hash utus? Because then we need to pass that too, right? Oh, internal too? Okay, never mind. The main separator. Yeah, let's put everything. Basic folder 1, chain. Here they put the digest. The digest is the domain separator, and the struct hash is the stuff I want to do, right? So here should be hash, and I just need to confirm that one. That should be right, I think. And name version, chain ID, the address. Address. Who is address? there. I think it's the forward indeed. Yeah, it should be the forward indeed. Yeah, that's all right. It did just, we go here. Just and let's execute. Let's execute. If that fail at signature, we need to remove that one. And if fails something else, we're gonna figure out. Yeah, invalid signature. Let's go remove that one. Maybe it's something else different, but nice. So they don't need it. Okay, so what we missing here? The address, right? So now we are calling. Now we are requesting signing by the player and make they execute the withdraw where they inform for the recovery to take the money, right? And because that's called, oh, the out of a gas. Oh, really? They check for gas? Oh, gas then? I don't think that works that way because that's assembly. Let's go max 2. Why not? That's not the way to copy stuff. Nope. Wait. Yes. No. Yes. That's the way to copy stuff. That's not the way to paste. I don't think that works. Damn. Yeah, but they took the recover. They took the address. And then they call something. I don't know how it is. And they get out of gas. No, I don't know if it works. All right. Okay. So now they call, but they have underflow invalid FE operation opcode. Okay, just let me check the executes. So that's my address. That's the target. The value is 0. That's the gas. And here the data. The data is calling that function. And that function is the withdraw. That function is the withdraw. We can check with the cast. If you go cast sign, I don't remember. Help. Get a selector for a function. Is that? What? Oh, they don't have. Yeah, see, that's the withdraw. So we are calling withdraw with amounts there, and the receive address all together, and they are taken under flow overflow because we are trying to take money that this sender don't have. So the error is getting here before they subtract. So we need to deposit something too, right? To do not have underflow here, because that's basically zero. That's gonna works, that it's failing by nature. So we need to do deposit. So we have some deposit function here. So that, for example, or that even. But let's think, because I need to call deposit, and that's that's private. Okay, yeah, that's payable. So I need to call deposit sending the value that I want. So here I need to do the trick. I need to take some money. So we did a loop, right? With 10 times. So on that loop, we need to take some money and deposit. And then withdraw. Because after we deposit, they're gonna increase. And then we withdraw. We need to run 9 times. We need to run 9 times here. Right? And the problem is the receiver, right? We can have some money. Then we have deployer recovery. We don't have money. We have player, just have here the deployer has something. But we don't have something. We need to use player. Because the problem is I close it with something we don't want to close. The problem is after the flash loan calls for the receiver, they just do nothing. Just pay fees. So I need to take, how I'm gonna take one money. Okay, so I need to impersonate who has some deposits. So in that list, who has deposited something? Fee receiver has some money. So fee receiver has 10. So if we take 10, so let's say fee receiver, it's an address that we can impersonate here, right? So we can impersonate. Oh wait, we cannot impersonate because we need to sign as fee receiver, right? Okay, let me check again if that assumption is correct. But I'm almost sure that I cannot impersonate here in the execute. They encode with the request from, and the request from also is where they check who can sign. So I cannot impersonate here. Otherwise, if I can take it 10, and then no, I don't make any sense. Deposit some amounts. So if the value is 0, wait. Oh, it just need calls. No, that cannot be 0. If I call deposit, player never deposit, right? Because who deposits outside the pool don't have that updated. Huh. Can we avoid the overflow? No, we cannot. We need really increase the amount here. Only depositing, only deposit as fee receiver. Oh, we can change fee receiver. No, right? I think no. Now that's immutable in the constructor. Oh, they have some deposits here. Oh, wait. Oh, they have wet and poo. Who? Deployer. We are allowed to. We don't, because we don't have private key from the. We can create a private key from deployer, right? We are allowed to do that. A user deploy a sample content for their risk. You score all from the user and the pool deposit into the recover account. Yeah. We should be able to do that. To enable the chat, what's happening here? The history. What? What happened? What happened with the live stream? Testing. Looks like it's working. Okay. Yeah, for some reason, I don't think it's... Chat here is not working correctly. We are missing something here. I'm not sure what it is. But it's clear that the post is calling here with the initial value we need to take, but even that initial value here, it's not the 10 fees paid, because the fee paid goes to fee receiver address. Oh, wait a second. Transfer from... Oh, no, that works. Receiver. I was remember that we can create a something custom to intercept receiver, but on that case it works. I think the initial hack was exactly like that. You create a contract that can have a custom receiver function, but I don't think that works here because we are not, but we kind of are using, let's see, but we cannot modify, right? So here they did some deposits outside and transfer. So here 9 times, I can do 10 times, but don't make a difference. Can I not against? What I missing here? Draw. Yeah, I think even if I take the pool, they're gonna fail. Even if I put 1, they're gonna fail. Because that is 0, right? Just put 1 to see. But that should be failing. Oops, compilation. Yeah, I see. Because let's go back. Because who is signing don't have deposits. if we call deposit as player, we need to provide the amount. So here, if you call deposit, we need to provide the amount. In the beginning, they took the Ethereum they have and just deposit. So the way to revert, it's talking with that contract, right? Calling withdraw. That's gonna burn the tokens, giving us the Ethereum to deposit. So we need to take tokens and call withdraw. Can we call withdraw here? Wait, they are running invalid Defi OP code too? No, right? It's not happening that one, right? Gas left, it's less. That's a against grieving attack, right? Less than request gas divided by 63. For the gas. I put a lot of gas here. I don't think that's a problem. You can see we can hack the contract here to show the problem. For example, if I remove the withdraw, that's reverting, that should be working. Oh, yeah, one test pass, one test fail. Oh yeah, there's keeping invalid FE, so I have a gas problem too. Oh yeah, they have the transfer. Made. But the invalid, it's happening because of that. So here the gas are informed. Should be enough to call. But that's too big. So anything left should be less, right? I don't have a clue how much gas I need to put here to forward. 60 parts gas left. It means the real gas, right? Where is my code? Here. Right. Oh, now. Wait, I got back the code. Yeah, I got back the code. So yeah, they return here, but the rest zero less. Why did it increase the nonsense? Yeah, so missing because that revert. Oh, no. Can sender super sender? I think super sender calls sender, right? Yeah, sender calls. So who is he really calling? So fee receiver has 10 and the deployer has. So if the deployer take the money, can I wait as deployer take the money? I don't think so. Yeah, let's finish tomorrow. Everything in place. I'm putting the recovery here. I don't think it make difference. Let's see. I remember Foundry has some way to check all variables state. I don't remember exactly how to do that. Let's see. There away in Foundry to check mapping state values variables in test Foundry. Right. Almost sure you can take values there. Yeah, the load. think it's that load address lot, and you can read. Suppose a getter also have simply way inspect to take its lot. Yeah. So for example, for example here inside the pool, that's publics. We just need to pass the address. So for example, here for executes, I can go, I think it's console log, and it's not signature, indeed it's deposit for player first, and placing is pool deposits, yes, player, and then here, no, now I want to deployer, right, and player deposits, yeah, player deposits. I think it's the beginning. You see player 0 and the deployer has the money. So if I call what's the signature of the deployer, this should be taken, but I don't have private key from the deployer. I could take and sign as deployer. I don't know if that's right. Or if your player must have the 2 or less. 2 or less means 0. Then receiver, it's already empty. The pool is not, and the address need to receive everything. Yeah, I don't see a way that must have a way. We can find it later. How to? We have a Defi receiver too. So I knew I'm missing something. So the receiver. Oh boy. Let's go just 2. It's not receiver, right? Oh, the deployer, it's a receiver. Oh, of course. That's why they have everything. Yeah. So the deployer, it's the fee receiver. That's why they have all the money. The money. Yeah, they have all the money. Can I just change here? No way. That should be failing. If I change it to deployer here, that should be failing. Must fail. signature, right? No. Yeah, they need to do invalid signer because yeah, they cannot allow such thing. Can I see the function? No, just for here. Damn, so much. Yeah, that one. So who signs need to be also there. In case I'm signed with the fire, if I go deployer here, I can take all the money. But I don't know if that's what they expect. Yeah, they expect that solved by player, right? Not, but something else. So must have a way. So withdraw. Oh. No, wait. Can I call? No, cannot. Can I call deposit? Sign as player. Yeah, we can, but we need the amount. And if we go 0, I think I see a problem here, right? Here the expect Ethereum give me token. The user convert the Ethereums for token. But transfer the token for the contract. So they don't have a way to take back. Here. They... Where? Here. They transfer the same amount for the contracts. So the player don't have nothing. That's a bug. That's not a bug, right? Here's the people who calls. Here I can change if that it's called by the trusted folder. That has only one, that's the basic. Let's check. We have a bug here too? Well, we cannot have a bug here. If signer is different from, so must be equal. Okay, it's possible to sign and make it recover, return 0. All right. Not possible. But even if you take 0, 0, they're gonna look for 0 sender that don't have nothing there. Withdraw. So just deployer. I can now move from deployer to another. Some. I cannot change fee receiver. Withdraw. Need to be signed. I cannot sign with the contracts. Yeah, my problem is also the deposits. They lock. Now we need to have Ethereum. In theory, I could take a loan from token, right? Can take a flash loan from to token. If I have a custom contract, I can create a custom contract indeed. The problem is the player don't have any money anymore, right? Like the player don't have money. Because who's deploying here? Wait. What? I misunderstood. Wait. Who's deploying? The receiver is the deployer. I see. And a receiver. They don't have code data. They don't use code data. Yeah, that's literally paying fees. Basically put all my, if we don't put all money in there, what changes? So receiver has tokens. I don't change anything. If you try withdraw, I see now. And they create the pool, they deposit some tokens, some Ethereum, take some tokens, transfer the receiver. So the receiver has 10 Ethereum, he have 1,000. Here they accept as further the receiver. So I can make all that money go to that. If I call that directly, it's just gonna approve a pool. It's in this lot. Pool who is calling. Yeah, don't make sense. Gonna revert. They did the checks there. But also they just allow the pool address to do the stuff. Oh, they allow the pool to do this stuff. Transfer in that case, right? But we don't have a control. That to receiver. What the hell? If I call deposit as player, I need to have values. I probably don't have. So that's gonna fail. I just let take the call. Just to for everything, pool, deposit. I think it's value 1, right? That's gonna fail as sufficient stuff out of funds. Yeah. And the withdrawal burn is gonna be the same for the these. I can create a contract, and let's see, I can create a contract, and they're gonna give me I think that's the part that's missing, right? I need to create a contract. Can I create here? It's not the best practice. Oh, here I cannot. I can't create it upside. No, upside is gonna be too ugly. Contracts. Hack. Flash. On receiver. Basically, it's a copy and paste. So it's more easy to copy. Paste. And wait, no. Trash. Paste here and then rename to hack. No. Hack, yeah. I'm sleepy. And here we can do whatever we want. It does need to repay. Right. So here we can delete. So put myself as receiver. They're gonna transfer me some Ethereum. I'm gonna burn. I'm gonna burn. I should be able to burn, take Ethereum back, deposit in the pool in the name of the player. Then, because I did the deposit, of Ethereum, I can take back, but that don't change anything, right? How I take back without changing? So that's the question. How I take back? Really? No, I cannot accumulate anymore instead fee. I can deposit. Oh, wait a second. So here I deposit the Ethereum mint tokens, right? And here I transfer token. Mint transfer, never burn, never burn. Yeah, there's something here. Okay, gonna see tomorrow then. But we are close. We are close. We did the transfer here. We manipulate the signature, but it's missing something. I think it's close to the loan. But the problem is I don't have money to pay the fee. How am I gonna pay the fee? Do not touch. I know. If I take all the money there, oh wait, if I take all the money as flash loan and deposit, now burn first, then deposit. Oh, wait. Because, oh, I think I found, right? They transfer, you never check. He never checks. He take my money with the fee. It just sum up. Okay, that's the thing then. So I think I can take the flash loan, take all the money. So that should be 0. Yeah, I think I need to pay with the fee. Okay, let's take him all money first. I take 1,000. Take 1,000 amount, and then we burn, and then we deposit. So now I change the hands. They're gonna go up again. But they never check, right? So we don't care about that one. And the problem is here. They check the callback. They we can have a problem here if that's less than 0. But here they don't never check. So basically we can take money and the amounts. Can we change the amount? So here we take 1,000. Then they take it back 1,000 more fees. And it's okay if and the process to take and give back, we can increase that variable for our player. And to do that, we need to just take the money. We need to pay the fee. Wait a second. Can I really create something? Yeah, we can, right? They don't check. Yeah. Yeah, that can really works if I have money to the fee. Just because transfer from gonna fail if I don't have enough money. Oh, I have the money. They don't check, right? So for example, I receive the money. Amount to be repaid, amount more fee. If I approve less, it's gonna fail here. If I take 1,000 and I need to pay 1,001, I cannot escape that constraint. Receiver to this. Yeah.